Okay, we're back to week 7, part B. When we were interrupted, had just calculated the z values that correspond to 15.95 and 16.05. The question now is, what's the probability associated with those z values? That is, what is the probability that the weight of a randomly sampled jar of jelly will be less than 15.95, less than the negative z value, and what's the probability that it'll be greater than 16.05? The sum of those two probabilities is then the probability that the weight will lie outside of our acceptable range. Now the two values, you may recall, get this down here so we can see what we're doing, were minus 3.493 and plus 3.1. Those aren't right. B43 minus B. Oh, I was messing around. I've got the wrong value I changed this while we were away. It should be 0.00. I'll show you what I did. 245 in a minute. That's our real standard deviation. So our, well, if I could type right, it's 0.245, right? Yes, there we go. Okay, our two z values were minus 2.13 here and plus 1.94. So you can see that the right-hand limit is slightly closer in. It's a smaller number than the left side. That's because the assumed mean of 16 is different from the measured mean of 16.002. And that accounts for the difference. Okay, probabilities. How do we find these probabilities we want? Well, the table is one way to do it. What we do is we take the z value of 2.138 and we enter the table. So here's a minus 2.1, but now we want 2.13, so we have to go over here, but we're really going to 134 is a little bit closer, don't you think? So let's just use that since we don't have an exact value. So I can type it in as being 0.0, well, wait a minute, why am I typing? Let's just point. It's equal to this value right here, 0.0162. Right? And this one is equal to, now wait a minute, you got to be careful because the area that this table is going to give me is the area to the left of the z value. So if I get the area to the left of this z value, that's not what I want. I want the area to the right of the z value. Now the good news is that the area under this curve is exactly 1, as we know. So all I have to do is subtract this probability from 1 to get this area. So I type equals 1 minus, now I need to find 1.94. So I go to the positive side of the table. 1.94 is right here, 9738. And that comes out to be exactly 0.03. What are the odds of that? You probably calculate that, but let's just add them up. Equals sum of these two values, 0.0424. And if we look in the back of the book, oh, I hope I got the right answer. I think I did. Let's just double check. It'd be awful if I got the wrong answer. 6.0424. Yes, I got it right. Great. Okay, so that's what, again, telling us that the probability that it's going to lie outside of these range, these limits, is 4.24%. Now, is that good enough? Well, the statistician can't answer that question. Only the business person can. Is it good enough to be 4.4 percentage points of uncertainty? There's a 4% chance we're wrong, is what this is saying. 4% chance that we could fall outside the range, even though we think our machine is pretty well adjusted. We could have a bad day. Now, the first question is, would the Federal Trade Commission and other regulatory bodies let us get by with 4%? This was a life and death medical device. We might want a 1%, even better tolerance than that. But for business purposes, maybe for the jelly business, 4% is good enough. In fact, advertising is usually run on a 5% basis. So from that point of view, we'd be doing okay. Now you can use Excel to do these same calculations if you want. It's a lot easier in many respects, although you have to keep the picture in mind still. And we'll use this norm dist function I was talking about earlier. I'm going to use the version that is not the standard, it's the regular one, dist. And it's asking me, first of all, for the value of x, then the mean and the standard deviation. So the value of x in the first case is 15.95. That's the lower limit. The value of the, I'll move this up so we can see what we're doing here. The value of the mean is that value, 16.0024. And the value of the standard deviation is here. Now this cumulative thing is a parameter that causes confusion, but if it's 0, meaning not cumulative, then it just gives you the height of this curve. In fact, this is the function that I used to draw this curve originally. It told me how many units up to go for each point on the curve. Hasn't much meaning when it comes to statistics calculations we're doing. We want the cumulative, which gives us the value of the area under the curve up to that point. So I'll put in a 1. And that gives us 16.227, 0.016227, which is pretty darn close to 01622. Not exactly the same, but close. And the other value then is equal to, now remember I have to subtract this from 1 because just like the table, Excel is going to give me the area to the left of the point and I want the area to the right. So it's 1 minus norm dist of x, which is 16.05 now. The mean, get back to where we can see it, the mean, the standard deviation, and cumulative, please. And that gives us 2.6. Now these values aren't exactly the same, and that's because we were doing some rounding before, right? We didn't have an exact match on our table. So when we add these up, I'm just going to copy this cell, edit copy. Control C is a copy, by the way, and Control V is paste. So you can see we got a slightly different answer this time, 0.422 instead of 0.424. Why is that? Well, it's because of the rounding, the fact that we didn't have a precise value from the table. From a business person's point of view, is this good enough? Of course, the table is perfectly adequate. The difference between 4.2%, 4.24%, and 4.22%, who would ever care? If you went to your boss and said, well, boss, I'm off by 0.004%, he or she would laugh you out of the office. That wouldn't be good. Okay, we could also use, just the last few seconds I have here, we could also use the other version of it, which is NORMS DIST. Now the S stands for standard, and instead of putting in the X value and the mean and the standard deviation, it's asked for a Z value. And since we've already calculated a Z value, that's no problem. We already have it. There it is, 1.6227, just like before. And 1 minus norm standard distribution of that. Whoops, I forgot the equal sign. That's what happens when you don't put an equal sign in. Excel doesn't know you're talking about an equation. That value is the same, and I add them up, and I get the same total. Okay, that's all there is to it. I say all there is to it because it is a complicated thing to get your mind around. I don't think the arithmetic, the math, is all that difficult once you start thinking about the areas under the curve and how to use the tables. But until you've done it a few times, it is a little bit confusing. For me, the only way I can keep my head straight even now is to think about or even draw this picture. And so I'm encouraging you, in fact, requiring that in the assignment this week, you draw this curve for me and for yourself so that calculating the probabilities, you can use it to do your calculations. That's all for this week. Thanks for listening. See you online.